3.6 is about inequalities, and more specifically, polynomial and rational functions inequalities. That means we've got less thans, greater thans, something like that. So the first thing we're going to be doing is get everything on one side. It's just so much easier that way. The next thing we're going to do is find our critical values. These are the most important x values. These are your zeros, your vertical asymptotes, things like that. Thirdly, we're going to make a sign chart. That's the sign of all the y values. Sign meaning negative or positive, not sign like in trig. Then we're going to pick the intervals of x that make y positive or negative depending on what we're looking for in the problem. So we're going to start off with a pretty easy one. So the first step is to get everything on one side. So all I have to move is that 14 on this problem. And now I've got x squared plus 5x minus 14 is less than 0. Step 2, find the critical values. So I want to find my zeros. So it'd be best to factor. Okay, so I'm going to factor this. And that's going to give me x plus 7 and x minus 2, because they multiply to be negative 14 and add to be 5. So this gives me my critical values are x equals negative 7 and x equals 2. Now those aren't my solutions to this problem because this is an inequality. We're talking about a shaded region on a number line. So let's make a number line. These are my critical values. They're my most important points. So they're the only ones I need to worry about on the number line. Now I need to think about whether they're going to have open circles or closed circles. Well, they're going to have open circles. Why are they going to have open circles? Because this just said less than. If it had said less than or equal to, they'd be closed circles. Now I need to figure out where to shade. So here's where I do this sign chart. I'm going to pick a number in this section. It doesn't matter what it is. Let's say I pick negative 10. And I plug it in here. I get negative 10 plus 7. That's a negative number. Then negative 10 minus 2. That's a negative number. What happens if I multiply a negative times a negative? I get a positive. Now, let's pick a number between negative 7 and 2. 0. 0 plus 7 is positive. 0 minus 2 is negative. So if I have a positive times a negative, I'm going to get a negative answer. I'm going to put that underneath because that's a negative y value. Pick a number after 2. Oh, no, 3. 3 plus 7 is going to be positive. 3 minus 2 is going to be positive, and a positive times a positive is positive. This is called a sign chart. Positive, negative, positive. And if you think about the way this graph would look, this is a quadratic that's positive in front, so it would have been above the x-axis, then below the x-axis, and then above again. So positive, negative, positive. So there's another way to figure out positive, negative, positive is to look at the graph. All right, which intervals do we want? The ones that have the plus or the ones that have the minus? Well, since this is less than 0 means we want negative. So what interval of x's is negative? Well, that's the part that we marked it with a negative sign. It's between here and here. So how do I write that interval? Well, it's from -7 to 2, not including them. So we'd write it as -7, 2 with parentheses. Example 2. Step 1, get everything on one side. So that just means I need to move the x over and the 2 over. That's not too bad. Notice this one now is greater than or equal to 0. That means I'm going to have closed circles, and I'm going to be looking for positives. But I need to factor this. So I'm going to kind of come off to the side and factor that. I'm going to use my factor box. I'm going to plug in each of those 4 terms. And now they are grouped. So I'm going to start with the first row. They both have an x squared in common. This has a -1 in common. X squared times x, and this would be a +2. So I have x squared minus 1 times x plus 2. This can factor again. Now remember, this is going to be greater than 0 is positive, so I'm going to have to remember that. And I need to know my critical values. Well, that's going to be x equals -1, x equals 1, and x equals -2. Those are my zeros for that polynomial, so those are my most important numbers. So I'm going to come back over here and draw my number line. So, -2, -1, and 1. And they are going to get closed circles. Closed circle, closed circle. Now, we can do the same thing we did up there and pick out numbers and plug them in. Or we can think about what this graph looks like. It's x cubed. An x cubed would start at the bottom and then go to the top. So this one would start at the bottom, go over the x-axis, touch, go back down, and go back up. So down here, it's below the x-axis, so that's negative. It's above, so that's positive, negative, positive. And we want the positive section. So I'm going to shade from here to here and shade from here to that arrow. So I want the interval from -2 to -1, and it's going to have closed brackets this time. And then the next interval starts at 1 and keeps going on forever, so that's 1 to infinity. Next example. And feel free to try this one and then come back and check your answer if you want. Get everything on one side. Less than 0 means we're going to be looking for negatives. Make myself a note of that. We're going to be looking for negatives. I need to factor this. common, x up here, -3, -9. So I have x squared minus 9 and x minus 3. This can factor again. That's x plus 3 and x minus 3. And there's another x minus 3. Oh gosh, what did that mean when I had a repeated 0? It happens twice. Well, if we think back about in 3.2, if it happens twice, that means there's going to be a bounce on the graph. Ooh, that's going to come in really important when we get down to, speaking of which, these are my critical values. The graph, thinking about how it will work. So, let's see, 0, -3, and 3. Now, if I did the picking a number and plugging it in, just wanting to show you that you could still do that. So, to the left of -3 would be like, oh, I forgot to do open or closed circle. Yep, these are closed. Good call. Okay. So, left of -3. Then we're talking about -5. Okay. So -5 plus 3 is going to be a negative number. -5 minus 3 is a negative, and then I'd have another negative. Negative, negative, negative gives me a negative. Between -3 and 3, I'm going to pick 0. 0 plus 3 is positive. 0 minus 3 is negative. And another negative would give me a positive. Bigger than 3, say 5. 5 plus 3 is positive. 5 minus 3 is positive. And another positive. Overall, it's positive. This graph would have gone up, came back, bounced, and then went up. So I want anything that's less than or equal to 0. This was a little tricky. Less than is here, but this point, it's also equal to 0. So this one has a little bit of a trick to it. We've got this -infinity to -3, but we also have the point 3. Because it said less than or equal to. So it actually includes that point. Okay, those were all polynomials. So what about a rational function? What about well, the first thing I want to do is get it all on one side. Okay, so we know we're looking for positives. That's easy. But I also need to know my zeros and my vertical asymptotes. Well, the easiest thing to find is that vertical asymptote, right? Because x plus 3 in the denominator makes it vertical asymptote there. So at the point -3, my graph can never, ever, ever touch it. So this is going to always get an open circle because it's a vertical asymptote. This is going to be an open circle no matter what. Now the next thing I need to find is any zeros. And this little 2 thing is kind of throwing it off, or else I could just say, well, what makes x plus 1 equal 0? The 2 is throwing it off. So I'm going to come off to the side and change this up a little bit. I want to know when x plus 1 over x plus 3 minus 2 equals 0. This is finding the 0. Now there's a couple of ways we can do this. I can find a common denominator and then do it that way. But I'm going to show you a faster way. Since we've already designated our vertical asymptote, we know that's going to have an open circle. I'm going to take this and do something a little crazy. I'm going to set it equal to 2. I'm going to move the 2 right back. I'm going to cross multiply. Now I can only do this because I've already stated that my vertical asymptote happens there. I get x plus 1 equals 2 times x plus 3. Well, technically it's a 1 times x plus 1. X plus 1 equals 2x plus 6. Subtract the x, subtract the 6, I get negative 5 equals x. That's my 0. That's my other critical value. So now let's get to the number line. Let's go back. Negative 5 and negative 3. If I pick a number, let's say negative 10, I'd have a negative, let's see, that'd be negative 9 divided by negative 7. This is where it gets a little tricky, and you might actually want to use your calculator to do some kind of guesstimatings. Or if you have a graphing calculator or Desmos, you can actually put the equation in the calculator and look at the table to figure out your positives and negatives. So I'm going to do that. I'm going to do a fraction. I'm going to do x plus 1 over x plus 3 minus 2. And I'm going to look at the table. Now, I'll show you how to do this in Desmos as well. I need to go to like negative something before negative 5. You see, negative 5 gives me 0. It was a 0, which, by the way, it's going to get a closed circle because it is 0. This is going to have an open circle. Okay. So before negative 5, all these numbers are negative. Between negative 5 and 3, which is only negative 4, it's a 1, so it's positive. Then after negative 3, it's negative again. I'll show you real quick how to do that in Desmos as well. But first, we'll go ahead and write the answer. We want a greater than or equal to, so that's positive. So that's just the numbers between negative 5 and negative 3, including negative 5, but not negative 3. Now, real quick, I will show you how to do this in Desmos. Let me pull up Desmos. And then I'm going to have to start graphing. In Desmos, I could type in, I could put f of x if I wanted to, but y equals x plus 1 divided by, and see, it didn't do it right. So if I press divided by here, it makes the fraction. And I'm going to do plus 1. And in the bottom, I'm going to put plus 3. And to the right of that, I'm going to put minus 2. Now, I can see on the graph that to the left of negative 5, it's negative. Between negative 5 and negative 3, it's positive. And then after that, it's negative. But if you also want to double check, if you click this, you can go to a table and you could type in, let's say, negative 7, negative 4, and positive 5, and see that it's going from negative, positive to negative. That's also how you can use Zoom to answer those questions too. And that is 3.6.